Okay, now I want to talk about an algorithm of search in an array. So the goal is going to be to find the index of an element in an array, or if it even exists there at all. And I definitely gave a drill on something like this, but let's look as an example. Let's say that we want to find the number 46 in this array here. So I start at index 0, then I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I find that that exists at index 11. So I can do this in code pretty easily. I'll make a method called linear search. It takes an array, the length of the array, and the number that I'm looking for. So if it doesn't exist in the array, by convention, I'll return -1. But if it does, then I'll return the index of the first occurrence. So I'll also have a Boolean that says whether this has been found yet. And I'll break out a loop if it's been found. So I'll say for int I equals 0, I is less than n, and I haven't found it yet. And not found. I plus plus. So what I'll say is if x at index I is the value that I'm looking for, then I'll say, yep, I found it, and it's at index I. So that's it. So let me just check to see. I was looking for this number 46, and I said it was at index 11. So if I say printf I, so I'll say linear search x, there are 17 elements in it, and I'm looking for the value 46. If I do this, oops, this should give me 11, right? So I'll run array search. Sorry. I was running this under Linux as well. Okay, so it gave me 11. Cool. So that seems to have worked. But there is a better thing we can do if the array is sorted, right? And this array is sorted. You see the numbers are in ascending order. So if I was looking for the number 46, well, I can ask a better question than going along. Is it 0? Is it 3? Is it 8? Is it 13? I can do something much smarter if I consider a range, if I consider the range that I'm looking in. And then I go halfway in between. So this has 17 elements, so the halfway point would be, so here's the first 8. So the halfway point would be here. And so let me ask the following question. So is the halfway point less than the value I'm looking for? So I'm looking for 46. Is 32 less than 46? Yes, it is. So what I can do is rule out 32 and everything to the left of it, right? Okay, so I bump this over by 1. And now I'm going to find the center of this range here, which, you know, there's not an exact center, but I'll just pick one that roughly divides them in half. So I've got 3 to the left here and 4 to the right. That you can do by just taking one index plus the other quantity divided by 2. Integer division will round you down. Okay, fine. So now I ask the question, is this less than the value I'm looking for? Well, no. It's not less than. It could be equal. So I can't rule this out. But I can rule out everything above it because it's not less than the value I'm looking for. Okay. So now I've narrowed it down to this range. Okay, let me go halfway again, roughly. And I say, is this less than what I'm looking for? Yes, it is, actually. So I can delete it and everything to the left of it. Bump this one over. And now I look for the midpoint between these two. And actually, it's just, you know, there's only 2, so I'll put it here. And I say Is 46 less than the thing I'm looking for? No. So then I actually move this over, and as soon as the two ranges coincide, my left and my right range, I check and see, okay, is that number 46? Yes, it is. I found it. Okay, so it's repeatedly dividing this in half. Let's look at another example to make sure this is clear. So I'll use the same array, but I will try to look for a different value. So let's say that I'm looking for 8 now. All right, so I say, is 32 less than 8? No. So I can rule out everything to the right of this. I can't rule this out because it could be equal. I didn't say less than or equal. So, all right, I can rule out everything to the right, but I have to keep that there. So now let me find the center here. Okay, so this happens to be right there. Now I say I'm looking for 8. Is 14 less than 8? No. Okay, so I can rule out everything to the right of 14. And now I'm here. Is 8 less than 8? No. So I can actually rule out everything to the right here. I know you're probably screaming at this point. You're like, I found it. But trust me, it's if you just follow this recipe, you'll avoid some very common bugs. Okay. So now I'll go halfway here, and I'll say, is 3 less than 8? Yes. So I can cut this out, bump this over. And actually now I'm at the point where the two indices line up, so I can check and say, is 8 8? Yep, I found it. Okay, now one thing you noticed is, so to get here, how many divisions did I do? I did 1, so I checked this value here. I checked this value, I checked this value, and I checked this value. And then I checked this value. So that was 5 steps. Versus if I had done a linear search, it would have only taken me 3 steps. I would have gone 0, 3, 8. That's just because this is at the beginning of the list. But in general, this dividing is going to be much faster. And it's particularly much faster for things that are beyond log base 2 of the length of this list. So for the majority of the elements in this list, this scheme will win. All right. So I want to try to translate this into code, and I'm going to have you finish the code in the module. So let me define the API here. So I'll say int binary search in x. And this time, instead of passing along the length of x, what I'm going to do is I'm going to pass along the first index and the second index that I'm looking between. So here I'm starting off on, this is index 0, this is index 16. So that's what gets passed along. And I'm setting this up to be a recursive function because really I'm doing the same thing every time, but I'm doing it between 2 different indices. So this can be implemented recursively, actually. Okay, so I'm looking for a particular value in the sorted array. Just like before, I'll say by default the index is -1. And here's the stopping condition. Remember, if the 2 line up, then I can't go any further. So that's my stopping condition. I can't divide it anymore. So if I1 is I2, then I check to see if x at that index is the value I'm looking for. Then my index is that. Okay, cool. So that's when you find it, and that's when you stop. Otherwise, we're going to do this. We're going to say, is the halfway point less than the value I'm looking for? So what I'm going to say is if x, okay, actually I've got to figure out the halfway point first. So remember I said, okay, yeah, it would be the average of these two. Now it turns out, remember we have to do some rounding down sometimes, but as I said, you can do that just with integer division. So I'll just say the midpoint is going to be I1 plus I2 quantity over 2, and that's fine. So that's this index. Here was index 8. When I went here, it ended up being, so this was 8 plus 16 over 2. That gave me 12. So 8, 9, 10, 11, 12. So you can see that this doesn't divide it quite evenly, but that's what we had done before. Okay. All right. So I'll say if x at the halfway point is less than the value I'm looking for, then I'm going to call binary search on some range. Okay. So I'll let you look back and figure out what that range is. Otherwise, I'll call it on another range. Okay. So your job is going to be to figure out what are those recursive calls. And at the end of this method, you should return the index. Okay. So it's actually pretty quick implementation recursively, and it's very efficient. But you have to think a little bit, well, what are these ranges that I can narrow down to each time? So look back at the example I gave and see if you can figure it out. All right.